Hello math fans, Dr. Andy Lovelace here. This is going to be pre-calc solving essentials. This is going to be about the four main inverse pairs. Addition, subtraction, multiplication, division, powers and roots, exponentials and logs. You really can't leave algebra or go into calculus until you're confident with those techniques. But really we can understand the basic ideas in about 5 minutes. So even if you don't remember, it's fairly quick. So I'm going to try to be very quick and practical here, and then I'm going to follow up with some skills because my students right now are learning about these. So let's get to it. It's really about, if you have had trouble with solving, the basic idea is you know those inverse pairs and you do them in the right order. That's really it. So if you're making mistakes, you're either doing it in the wrong order or you don't know your inverse pairs. And what I mean by that, so you have to, eventually we have to know this. It's not something it's just a practice. I see students, and it's perfectly fine to write -5 on both sides, but I really want them to just write 2. I want them to know that the inverse of addition is subtraction. It's just a button you push on this single basic calculator. You say, I have a 7, I need to subtract a 5. When I look at that first equation, we need to get to where we see it. If you want to write -5 on both sides, that's fine. But eventually, by the time you get into calculus, you want to be able to just see that. So I'm very practical in terms of what will be successful for you. Same thing here. I want to add to both sides. Done. And then you always have a fail-safe. So, when it comes to solving, you always can go back and plug it in. I'm surprised that a lot of students don't know this piece. So to me, solving should not seem like a big thing, because at the end you can check, and it's just pushing the right button in the right order. Okay? There are little things that can cause complication, but that piece of it we don't want to confuse us. So here we're trying to get rid of a 6. Now when we write this, the operation between them is multiplication. We're trying to undo it. So we're going to divide both sides by 6. 30 over 6 is 5. Here we're going to multiply both sides by 3. We're going to get 12. So the moment students start to have trouble, if you just sort of think back to whenever this happened, this is usually 6th, 7th, 8th grade, when you start solving linear equations, it's because they got in the wrong order. So you've already encountered this. You had to learn what to undo first. Do we undo the 1 or do we undo the 2? Right? So that was an order of operations thing. What's on the most outside, so to speak? Or what's most attached to the x? That will have to be done last. So generally, if you can do addition or subtraction to simplify, you would like to do that first. So like this one, you can subtract a 1 from both sides, and you get 8. So you're going to get, a lot of students would do this in 2 steps, so I better do it too. 4x equals 8. And then they would divide. So a lot of the challenges are just people getting in the wrong order. Now you can expand, that's fine. Or you can just do it in a certain order. I would divide both sides by 2. So at this point, I'm not going to recap that order of operations. So that requires a little bit of knowledge from the past, but not really. And you have the fail-safe, remember, that if you don't know if you're unsure, you go back and try it. That does require that you can do the calculation. But that you've done a lot. Okay, so I just want to really say, because I have people that say, oh, I always make mistakes. This is controllable if you really have a goal to go on into calculus. All right, so that's the first piece. Then we add these powers and roots, and that's where sometimes we lose students a little bit. And unfortunately, I already have the answers there, but hopefully these are quick. And I will do a follow-up video where I go through a whole bunch of examples. This is the setup for this, so I'll refer back to this. Powers and roots are just this. So I find that this is something you've definitely seen before. This is usually covered in like 8th, 9th grade math. But it's knowing what the cube root is. Now you can write it a couple different ways. You can write it as the cube root of 10. And I think my calculator has a button for it, but honestly, I don't even know how to use it. I will try. I think you have to do 3, and then you have to do this button, and then you do 10. Let's see if that does it. Yeah, I never ever do that, because instead I do 10 caret 1/3. Students think it's funny that I say caret, but that's it. Okay, and there's always, usually the mistake, the actual solving to me is not the mistake is arithmetic, which is a different discussion, but I want to separate that. When people say, oh, I'm bad at algebra, I think everyone can do this. So this is going to be 10 to the 1/3 or the cube root. If you're going to get rid of a square root, you're going to square both sides, just like we did here. Just like with addition and subtraction. Get rid of addition, use subtraction. Get rid of subtraction, use addition. Get rid of a power, you do a root. Get rid of a root, you do a power. Okay. So there are no plus minuses. There's only one case where there's a plus minus. I lined it up wrong, but it's this case. And that's because when you square and you have an even. So this is one of those, each thing has its little things. Like at multiplication and addition, you had to learn how to distribute and how to know which comes first. Powers have their own thing too. And the main thing with a power is the fact that if I have, x squared equals 4, there's two answers. And that's because -2 times -2, we defined to be 4. Now that's a different discussion. Why do we say -2 times -2 is 4? If you think of a negative as just flipping the other side of a number line, if you flip twice, you're back. So it's really a question of what we think of a negative is, how we've defined it. But anyways, that's it. That's the only time you have to think about the fact that there's two answers when you go from an even power to a root. So this is it. This would be the only one of these 4 cases. I find that it's not very many. It's something that many students don't know. So it's 4th root, but I'm going to write it in the way I suggested. So we're going to do 17 to the 1/4. This is also a power. It's 5th power and cube root, but it's easy to write. You write 5 to the 3/5. So that's your starting place. In fact, I already have a video in my pre-calculus class about that. That's like, I would say pretty much a long ways into whatever, all the way through 8th grade math. That's your toolbox. And then you have combinations of them. You have to do them in the right order. And this is the order of operations. The one further down has more precedent. Okay, then the last one that, depending on your high school or you've seen this a lot, but I find people just have varying amounts of comfort with it. And that's what I'm teaching right now in my class. So I'm just going to finish out the inverse pairs, and then I'll do a whole bunch of solving with them in the next video. So yes, these have a funnier name. They look a little funnier because it's logs. There's an interesting and long history of these, but it's the same sort of thing. The inverse of this is this. It's really just a button you push. You type it in funny. You say log of 7, but every new operation we have to know how to type it in to get it. It used to be you'd look in a book or whatever and have to look it up, but it was given a name. Same thing goes the other ways. If you want to get rid of a log, you exponentiate. So that's going to be e to the 20th. So in some ways, you're just learning the button to push to rearrange an equation. That's the idea of inverses. Now, if there's some other power, whether it's 2 or 10 or something else, we use the corresponding log, but most calculators don't have that. So if you want to calculate this, we use this change of base formula. Excuse me, that's like the special thing when it comes to log, is that you really only need one. Same thing like with roots, you had to know the plus or minus. So like I said, each inverse pair has its own little special properties you have to learn. I think that's what bothers people, but really it's not that bad. You do the log of 11 divided by the log of 2. And once again, at any point, if you are worried or confused, you do an example. You get this number, whatever it is, 3.45. And you go back and you plug it in. You say, is 2 to that number 3.45? So I like to remove all, confusion. I like to question every value I get, and I go, what if I do 2 to the 3 point? It's really good to not be doing math blind. If you know you're solving an equation, it's completely checkable. 11, yay. So to me, that a lot of students are missing that idea that that's really most of solving. There is trig and inverse trig, but that's its own thing I'll do separately. That's it. When I solve an equation, often there are many operations in one, but it's just using those in the right order. Okay, let me know if that's helpful. I'm going to follow up with a video where I actually do a bunch of solving.